You use Wi-Fi every single day. Probably used it to load this video, but if someone asked you what the difference is between 802.11n and 802.11ac, you'd just stare at them. Wi-Fi has gone through 8 major generations in under 30 years. Each one faster, stranger, and harder to name than the last. So let's start at the very beginning and work our way to today. 802.11. It's 1997, and the internet still sounds like a fax machine arguing with a robot. The IEE just dropped the very first wireless networking standard. No letter after it. Just 802.11. The defining feature was embarrassingly simple. It existed. You got a maximum speed of 2 megabits on the 2.4 GHz band. For context, downloading a single MP3 could genuinely test your patience. The hardware was massive and wildly expensive. A single wireless PC card could run you several $100s. Enterprise offices were the only real buyers. Nobody at home was touching this stuff. Ethernet was faster, cheaper, and didn't require a second mortgage. But here's the thing. 802.11 proved that data could move through walls without a cable. It was like the Wright brothers' first flight. Wobbly, terrifying, barely useful. But it left the ground. And that alone was enough to launch an entire industry. 802.11b. 2 years later, in 1999, things got real. 802.11b pushed the max speed to 11 megabits per second. Still on 2.4 GHz. Still not blazing fast, but fast enough. This was the generation that dragged Wi-Fi out of the server room and into your house. Apple threw it into the iBook with AirPort, and suddenly wireless internet wasn't just an office experiment. It was something you could use on your couch. The gear finally hit prices normal people could stomach. Routers dropped under $200. Coffee shops started offering free Wi-Fi, and the world quietly changed forever. Real-world speeds varied wildly depending on walls and distance. But it worked. You could check email without plugging in, and that felt like actual magic. It was like going from a landline to a cordless phone. Same call, but suddenly you could walk around. 802.11b didn't win on specs. It won by showing up where people actually lived. 802.11a. Here's the weird one. 802.11a also launched in 1999. Same year as B, but almost nobody bought it. It ran on the 5 GHz band and hit 54 megabits per second. 5 times faster than 802.11b on paper. Sounds amazing, right? The problem was physics. 5 GHz signals don't push through walls nearly as well. The hardware was more expensive. Compatibility with all those B devices people were buying was basically zero. It was like building a sports car in a world where every road was gravel. Sure, it was fast, but only in perfect conditions over short distances. Enterprise users loved it for dense office setups. Home users ignored it completely. The price premium killed it at retail. But 802.11a quietly introduced OVDM, a modulation technique that became the foundation of every Wi-Fi standard after it. It lost the popularity contest. It won the engineering one. 802.11g. By 2003, the obvious question had arrived. Why not combine the best of both? 802.11g delivered exactly that. It took 802.11a's 54 megabits of speed and ran it on 802.11b's familiar 2.4 GHz band. Full backward compatibility with every B device already out there. This was the no-brainer upgrade. Routers were affordable. Laptops started shipping with G built in. For the first time, Wi-Fi just worked without a whole research project. Real-world speeds hovered around 20 to 25 megabits per second, good conditions. Streaming music worked. Basic browsing was smooth. Video was still a stretch. It was like upgrading from a bicycle to a scooter. Not a race car, but suddenly the commute didn't hurt. Intel's Centrino platform baked Wi-Fi into laptops by default, and that changed the game entirely. If you used a laptop between 2003 and 2008, you were almost certainly riding on G. It wasn't flashy, it was everywhere, and sometimes that matters more. 802.11n. In 2009, Wi-Fi finally grew up. 802.11n was the first generation to earn a consumer-friendly name, Wi-Fi 4, though almost nobody called it that at the time. The big deal was MIMO, multiple input, multiple output. Instead of one antenna doing all the work, your router could use up to 4. Theoretical max speed jumped to 600 megabits per second. It ran on both 2.4 and 5 GHz bands. Channel widths doubled from 20 to 40 MHz. This was a generational leap on paper and in practice. HD streaming finally worked over Wi-Fi. Gaming got less painful. File transfers stopped feeling like watching paint dry. Draft-N routers had been floating around since 2007, so early adopters already knew the deal. Prices were reasonable from day one. A solid router ran you around 80 to $100. If you're old enough to remember when Netflix buffered every 30 seconds, 802.11n is the generation that fixed it. It turned Wi-Fi from a neat trick into actual infrastructure people relied on. 802.11ac. By 2014, the internet had a bandwidth problem. 4K video was emerging. Cloud storage was exploding. Households had a dozen connected devices fighting for air. 802.11ac, better known as Wi-Fi 5, showed up ready. It moved exclusively to the 5 GHz band. Channel widths jumped to 80 MHz standard, with 160 MHz optional. Theoretical max hit 6.9 gigabits per second on paper. Nobody ever saw that in real life. Not even close. But real-world speeds easily topped 200 to 400 megabits point-to-mid on decent hardware. That was a massive jump. Wave 2 arrived around 2016 and added MIMO so the router could talk to multiple devices at once instead of taking turns. Beamforming focused the signal toward your device instead of spraying it everywhere like a lawn sprinkler. A good router cost around $100 to $150. Premium mesh systems pushed well above that. Gigabit internet plans were rolling out across the country, and Wi-Fi 5 was the first generation that could actually keep up with the pipe coming into your house. If you're still rocking a Wi-Fi 5 router, drop it in the comments. In most homes, it still gets the job done. Wi-Fi 6. Welcome to 2020. The naming finally made sense. The Wi-Fi Alliance officially branded 802.11ax as Wi-Fi 6. Thank you. Seriously. The defining story here wasn't raw speed. Theoretical max hit 9.6 gigabit per second, sure. But the real breakthrough was efficiency. OVMA let the router divide each channel into smaller sub-channels. Think of it like a highway, adding dedicated lanes instead of just getting wider. MIMO improved to handle uploads too. Target wake time let devices sleep smarter and save battery. BSS coloring reduced interference from your neighbor's router. This was Wi-Fi built for the modern home, where 30 devices are all screaming for bandwidth at once. Real-world speeds landed between 300 and 900 megabit speeds, depending on conditions. Then in 2021, Wi-Fi 6E dropped. Same tech, but it unlocked the entire 6 GHz band. That meant way more channels and way less congestion, like finding an empty highway right next to the one everyone else was stuck on. Routers ranged from about $100 to $300. Wi-Fi 6E gear ran higher. This generation wasn't about bragging rights. It was about making everything else work better. Wi-Fi 7. It's 2024, and Wi-Fi 7 has entered the chat. Officially 802.11be. This generation is absolutely ridiculous on paper. Maximum theoretical speed hits 46 gigabits per second. Channel widths double to 320 MHz. 40096 QAM packs more data into every single transmission. But the headline feature is MLO, multi-link operation. Your device can send and receive across multiple bands simultaneously, not switching between them, using them at the same time. It's like driving on 3 highways at once, instead of picking one and hoping it's clear. Early real-world testing shows speeds comfortably in the multi-gigabit range. Latency drops significantly, which matters hugely for gaming and VR. The catch? Router prices start around $300 and climb fast. You need Wi-Fi 7 devices on the other end to take advantage. Most phones and laptops are just now adding support. For the moment, Wi-Fi 7 is the overachiever waiting for the rest of the world to catch up. Give it 2 years. It'll be the new normal. From a 2 megabits per lab experiment to a 46 gigabits per multiband monster, Wi-Fi grew up fast. 802.11b dragged it into the living room. 802.11n made it reliable. Wi-Fi 6 made it smart. And Wi-Fi 7 is just flexing at this point. We went from celebrating a web page loading without a cable to streaming 4K on 5 devices while a smart speaker argues with the thermostat. Not bad for something named after a number nobody can remember. So what Wi-Fi generation is your router running right now? Drop it in the comments. If this helped, hit the like button. It genuinely helps the channel. Next up, we're breaking down every Bluetooth version and what actually changed between them. It's a wilder ride than you'd expect. Click the video on screen right now.